Okay, so basically we have kind of started from the top and now we're here. No, started from the top and we looked at command versus market economies, and then somewhere in between is mixed, and that was kind of like a little less important, even though it's kind of a big deal. But I didn't talk about them because mixed economy is just a kind of some sort of middle ground where the government commands some and doesn't some others. Okay. Um, so after that, we specified market was one of the types of major economies, and then we had different kinds of markets. We had monopoly, and oligopoly. So monopoly had one seller. Oligopoly had a few sellers. Monopolistic competition had a lot of sellers, but they were a little bit differentiated. And then perfect competition had many sellers, and they were not differentiated. And then on the other hand, you have monopsony, which is a few sellers or many sellers and one buyer. Okay. So that all gave kind of how the gains from trade might be affected. So, like having a lot of sellers and a few buyers might tilt the gains from trade towards the buyers, and having many buyers and a few sellers might tip the gains of trade towards the I lost what I just said. Having a few buyers and many sellers would tip the gains of trade to buyers. So whichever one is less prevalent tends to have more market power, we say. But in order to like show that, I want to kind of formally define demand and how it relates to supply so that we can see the number of buyers and what they're willing to buy and the number of sellers and what they're willing to sell. And kind of see how those things, number of buyers and quantity bought and quantity sold and demanded and produced and all that, how that affects price. So I'm going to define a few things, and then we'll kind of work our way up to building a demand curve, and then we'll build the supply curve, and then I'll show you what's called an equilibrium, which is where price and quantity kind of converge onto one particular point, which is like a equilibrium point. It's like a static point. Okay. All right. So let's start with too fast, too furious. Quantity demanded. The quantity demanded denoted Q sub D. I use this little subscript D for demand, and I call it Q sub D, is short for subscript. Q sub D, the quantity demanded of a good or service, is how much consumers want of that good for a particular price or service. This is important. Again, too fast, too furious, and too fast for y'all. Hashtag ludicrous. For a particular price, that is an important element of this definition. Okay, you can't have quantity demanded without specifying a price. You'll never get a real number unless you know what the price is. Okay, if someone walked up to you on the street and said, "How many hot dogs do you want to buy?" Your answer is either none, because I don't want hot dogs, or if you do want some hot dogs, if you want a positive number of hot dogs, you'd want to know, well, how much are you selling them for, right? You're not just going to agree to buy 6 hot dogs, because then they'll say, all right, 6 hot dogs for $1,000. You want to know what the my hairline is terrible. I hate these videos. You want to know what the price is before you agree to demand for a quantity. Okay, so your quantity demanded is kind of related to your willingness to pay. So the willingness to pay basically sets the price you're willing to pay for a particular good. If your willingness to pay is greater than the price, you'll be willing to buy that particular good. And then remember, willingness to pay, is translating basically your utility into a dollar term. Remember, we had this idea of marginal utility, right? Where if I wanted to buy hot dogs and I got a certain utility from hot dogs, remember utility functions map the consumption, in this case, the consumption of hot dogs, how many hot dogs I consume, to how happy I am consuming it so that I can rank them, okay? And I kind of talked about this, curvature shaped utility function, what we call convex utility function, where the first hot dog, if this is 1, and this is 2, and this is 3, okay? Let's change the color here. Okay, the first hot dog, let's say this is 2, netted me like, let's say 2 utility. Okay, and remember, utility is just a number to rank things. It's not really important that it's 2 utility instead of 4 utility. What is important is that 2 is going to be less than whatever utility this comes out to. So let's say this is 3 utility, okay, and this is 4 utility. Usually I do dotted lines, but it's hard with the distance learning drawing on PowerPoint nonsense. Actually, I want to make this. I don't want this to be 4 utility. I want this to be lower. I want this to be 3.5 utility. Okay. So basically, as I consume more hot dogs, my overall utility increases, right? But as I consume more hot dogs, my change in utility, going from 2 to 3 or 3 to 3.5, decreases. And that's pretty typical. That's a typical economics assumption that we make. Basically, like, after a certain number of hot dogs, you're like, these hot dogs are gross. I'll eat them because I do kind of like the taste, but I don't know how many more I can eat of these, right? So, your marginal utility, the change in utility for each additional hot dog you consume is going down. Okay, that's diminishing marginal utility, we call it. So as marginal utility decreases, your willingness to pay will decrease, right? Okay, so I'm going to take the diminishing marginal utility as given, and I got here like a little setup where I have the number of hot dogs that 3 people want to consume, and then we're going to do what's called the demand schedule, which will be the next bullet point over. But we're going to do a demand schedule to see what the quantity demanded for a particular market is. Okay, so let's say Joe is willing to pay $10 for his first hot dog, $8 for his second hot dog, $5 for the third, $1 for the fourth, and 0 for the, let's say 0.5 for the fifth. Okay, so you know what, 0. Okay, and Jack is willing to pay 12. He's a big spender, Jack. He loves his hot dogs. Big old Jack loves his hot dogs. Number 9. I'm just throwing out some numbers here. 6, 1, 0. Okay, so this is their utility. You can see it's going down. In general, this is their marginal utility. You can see it's going down. So, like Jack's total utility would be 21. His change in utility would be like, so his change in utility would be 9, right? And then change in utility would be 6. Change in utility would be 1. Change in utility would be 0. But so the total utility is increasing, but it's increasing by lower and lower amounts. I'm going to fill these back in, actually. I do want positive numbers on there. Okay, and let's say he's willing to pay $8, 5, 4, 3, 2. Okay. So again, it's diminishing. If you were to plot this, basically his total utility in terms of dollars. So let's take John. John's total utility. John's total utility will be basically it's going to be the sum of this cell here. So I want row 2, column 4 to RC4. So this is John's total utility per hot dog. So if we like graph this, just to show you diminishing marginal utility in a different setting. So this is John's total utility here, okay, and this is the number of hot dogs, okay. So it's got that little convex or concave shape. For each hot dog John eats, and assume it starts with 0, 0, okay. For each hot dog John eats, he's getting less of a rise in utility, okay, at any rate. So let's go back to the example at hand. I should have put this on a different guy, whatever. So this, I'm just going to throw this graph on the side here just for now. Okay. And I'm going to hide this bad boy. Or, let's just break it apart. All right. So I want to know, for a particular price, does Jack, does Joe, and does John, or do Jack, Joe, and John consume a hot dog? Okay. So real quick, I want to introduce this concept of a demand schedule. So demand schedule shows how the quantity demanded of a good changes as the price of that good changes. Okay. So right, quantity demanded is corresponding to a particular price. Okay. So I gave you basically the utility that Joe, Jack, and John get, or their willingness to pay per hot dog. So if I give you a price, you should be able to know how many hot dogs will Joe consume, how many hot dogs will Jack consume, how many hot dogs will John consume. Okay. So, all right, let's start with Joe. If Joe is given a price of $0 per hot dog, how many hot dogs will Joe consume? Well, he's willing to pay 0.25 for 5, right? So he's willing to pay for them all. So Joe wants 5, okay? If it's up to 1, right, he's willing to pay $1 for the 4th hot dog, right? Oh, sorry, for 4. So the 4th hot dog gives him a willingness to pay of 1. The 3rd hot dog gives him a willingness to pay of 5, as a reminder. He has a willingness to pay of 8 for the 2nd hot dog. And the 1st hot dog, the one that gives him the most utility, he's willing to pay $10 for. Okay. So let's just fill in the sheet. So it should be 4 up until 5. So this should be 3. For $2, he's willing to pay for 3 hot dogs. And then at the 5th one, it should still be 3. And then at $6, he's only willing to pay for 2 hot dogs up until 8. And then anything above 8, he's only willing to pay, for 1 hot dog. And then anything above 10, he's willing to pay for 0 hot dogs. Okay. So this is Joe's willingness to pay for. He's willing to pay $10 for 1, $8 for the 2nd one, 5 for the 3rd, 1 for the 4th, and nothing for the 5th, or 25 cents he's willing to pay for the 5th. So 0 will be that one. Okay, let's do Jack. I'd say take a minute, see if you can figure it out on your own, do it in your notebook. Pause this video, and then we'll do it as a team, as a class. You, me, and all the other people who are watching at home. All right, take a second. All right, presumably you paused the video. So let's do Jack. Jack, the big hot dog guy. Jack, for $0, is willing to buy all 5. For $4, he's willing to buy, for $1, he's willing to buy 4. For anything between $1 and $6, he'll buy 3. For 7 to 9, he's willing to buy 2. For 10, so between 9 and 12, he's willing to buy 1. Okay. And then if I had 12 and 13, it'd still be 0 for Joe. For 12, it'd be 0. There we go. So that's Jack. What about John? Anything below 2, he's willing to buy all 5. Anything between 2 and 3, he's willing to buy 4. Anything between 3 and 4, he's willing to buy 3. Anything between 4 and 5, he's willing to buy 2. And then anything between 5 and 8, he's willing to, anything between 5 and 8, he's willing to buy 1. And then anything above 8, he's not willing to buy anything. Okay. So these are 3 individual demand schedules. Okay. This is the number of hot dogs they're willing to buy for a particular price. All right, I'm going to move this bad boy over, move it over. And then I'm just going to sum these bad boys up. This should be 5. Jack is willing to buy 5 for 0. Okay. I'm going to sum. This will be QD for all, or just QD in general. And I'm going to add these little critters up. Apologies if you guys can hear my cats. They're annoying as hell right now. This is their witching hour. All right. So here we go. Let's insert a graph. I'm going to do another scatter plot with a line. Is this guy? Nope. Where's my scatters here? All right. So this is our quantity demanded as a function of price. Okay. So on the x-axis here, I want to add some axes titles. So primary horizontal, this guy. In this case, it's price. And then primary vertical is quantity. Now I hate that Excel automatically assumes that I want quantity on the y-axis because that is annoying. I want to switch row and column. Nope, I do not want that. Let us quick layout. I want to. How do I switch? Haha, I know. Or maybe I don't. Select data. 12. 12. That did literally nothing. All right. Need 2 more minutes so that I can figure this out because it'll be helpful for you guys too. Why that's not doing anything. All right, at any rate, is there a way I can rotate this at least? This is annoying as crap. See if this changes things. It's not. All right, whatever. So in economics, price is always going to be on the y-axis. It's just the convention that we've had forever. And it's annoying that it's not letting me do this. But for what it's worth, you shouldn't be doing too many graphs in Excel anyway. Most of your graphs will be done in the drawing toolbar. But what did we just do? And apologies for the little interlude there to figure out the graph itself. But we just mapped for every price from 0 to 13 what the quantity demanded would be. And this relationship right here, this kind of like graph with like little connected lines, is a demand curve. Okay, the demand curve will map your demand schedule into like a little line there. Okay, so if we have price, we have quantity. Okay, you have your demand curve right here. Okay, so demand curves relate your price to your quantity demanded. Okay. One thing to note, demand curves are almost always downward sloping. This is called the law of demand. It's very, 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 very difficult to find a demand curve that increases with price. I read one paper in my life about that. It was subsistence rice in like rural Vietnam in the 1990s, where they found that as price increases, quantity demanded of rice increases. But there's a whole host of things going on there. But otherwise, it is not very likely. Yeah, enough said. Okay, so that's what I just said. The quantity demanded decreases as the price increases for almost all goods. Okay. So basically, this is a similar exercise, just just a little cuter. Okay, and this one has the price on the y-axis, so that's good to note. Quantity on the x-axis. That'll always be the case. This also added a supply line. So based on the mirror image, supply can basically tell you how many, based on what producers are willing to sell, which is essentially their cost. You can have a similar quantity supplied schedule, a supply schedule that'll map to a supply function like this. Okay, and then at this little point, this bad boy right here, we have what's called an equilibrium. Okay, and that maps some quantity sold to a particular price. Wow. Oh, I miss whiteboard. Yeah, whiteboards. Okay, and I'll formally define equilibrium in a slide or two. But basically, it's the settling point for the economy. This is like when the number of buyers and the number of sellers agree to a particular price, and everybody below the demand curve who's not really willing to pay a whole lot of money, and everybody above, everybody below the equilibrium price on the demand curve is not really willing to pay for a whole lot, and everybody above the price on the supply curve has a high cost, so they're not really willing to supply unless it's for a lot. Okay, so these guys wouldn't buy unless the price decreased, and these guys wouldn't sell unless the price increased. Okay, and then the ones who do want to buy and the ones who do want to sell kind of agree on a point, and that'll be this point of intersection.